Hello everyone, thanks for joining. This is Melony Qin. I'm a program manager at Microsoft. Today, our session, we're going to talk about administrating SQL Server big data clusters. The agenda for today, we'll start on talking about architecture, basically how we design a product and different OSS components. Then we're going to talk about how to manage and operate big data clusters on different tools to support different personas. Then dive into monitoring and troubleshooting. Our challenge of the day is really about no buzzwords. I know there's a lot going on in the cloud native and data and AI community. Our session will be focusing on supporting you going through the challenges in your real life project. Also, a very interesting factor here, BDC celebrated its first birthday in November. It's been so exciting journey by far. And even more exciting is that we have a lot of great features coming up in the next year. So if you guys are ready, let's get started.
Traditionally, when we are working with containers, probably on your laptop or on a physical server, we have a few containers, one or two. It won't be too challenging. The real challenge is really comes to when we have multiple containers to work with. So to overcome those challenges, we need a mechanism to help us operating and manage those containers effectively. So that's where container orchestrator comes in. And Kubernetes is one of the most popular container orchestrator in the cloud native community. It adopts master and slave architecture, which is very clever as architecture because it separates the concerns while the workloads to be managed and executed. Also, the communication is exposed as an API call. So when an end user trying to talk to your Kubernetes cluster, usually their request going through the API server, which can be translated as an instruction, then through different operations sent to different worker nodes. The master, of course, we have a few components for the master, but in a nutshell, you can see master as a captain of your cluster. That's where we define the work, also distribute the work to the worker nodes. When it comes to worker nodes, you can see the worker nodes is where your container are actually up and running. In the Kubernetes world, we call it as a pod. Inside that pod, it can be one container or multiple containers. So each worker nodes, they have a kubelet agent. Also, you have a container runtime on that node. So the other pods will be sharing the compute resources of that node. When it comes to some public cloud provider, either using Microsoft Azure or other cloud providers, basically the worker nodes can be represented as a virtual machine or a group of virtual machines. But basically, all those virtual machines, they actually provide the compute resources to your application deployed on the top of Kubernetes. And in some cases, especially for the managed Kubernetes clusters, they usually have some resources can be reserved, such as memory usages or CPU usages, are reserved by some system process. On top of Kubernetes, as we mentioned, we can deploy stateless workloads, such as a regular application or an API. It can also be deploying some stateful workloads or data processing workloads. That's where we are going to talk about big data clusters on top of Kubernetes. So big data clusters is a good example of a stateful and data processing applications on top of Kubernetes. So the reason I'm saying that is because we can attach a storage to the pods. The storage in Kubernetes world, we call it as a volume or persistent volume. The persistent volume is in our case, which can independent from the life cycle of each pod. And when we talking about persistent volume, of course, we also have persistent volume claims. The BDC is where we define how much storage and what type of storage we're going to attach. We were saying master is the captain of a Kubernetes cluster. When it comes to a big data cluster, we also have a captain, which is our controller. Controller is the component that dealing with the coordination of different components inside the big data clusters. It talks to config store, which is a component that stores the metadata of big data clusters. To get more insights about what's going on inside your big data clusters, we provided Kibana a graphic dashboard. We'll get to that part more in details later in the session. Both of them can be accessed through proxy for security reasons. For most DBAs or data engineers, you may be familiar with SQL Server master instances. So from your laptop, you can use Management Studio or Azure Data Studio connected to SQL Server. The external data, such as data from Oracle or from MongoDB, it can be queried using Polybase. And the SQL Compute Pool is there to provide computational resources, especially when we need to process some specific tasks. For external data ingested by Spark jobs and SQL queries, it can be cached in data pool. So data pool is where we can cache all those part of data, and as a data mart persisted in a ephemeral storage. We also have storage pool. Storage pool is where we have HDFS cluster, also for the storage part of SQL Server. So all the storage pool nodes are members of our HDFS cluster. Finally, we also have a net pool. Net pool is where we can deploy applications in big data clusters, which consume the big data and relational data in big data clusters. Also similarly, for security reasons, it can be accessed through a proxy. SQL Server Big Data Clusters. It combines SQL Server relational data and Spark Big Data. Altogether, it can be served as a data lake, as data hub, so combine those data in a central place. As we know, one of the biggest challenges today is to integrate different data sources from many different places. So Big Data Cluster is this kind of platform to help you overcome this challenge. Also, using Polybase, it's possible to analyze based on those data, so writing up queries to generate meaningful insights to support your business decisions. As a complete AI platform, we also support Spark ML and SQL ML. So based on all those big data, it's possible to train a model and deploy those models. As a complete AI platform, we also support the whole life cycle of data processing, from data ingestion, data training, modeling. So it's a comprehensive big data analytics platform. Knowing about the different components of big data clusters will help us to lay out a groundwork to work with big data clusters, especially when it comes to managing and operating big data clusters. We need to know some more specific components. So now let us to put them under a microscope. Knowing that deploy big data clusters on top of Kubernetes means Kubernetes provide infrastructure to host different components of big data clusters, which is why to manage big data clusters, firstly, we need to consider if you have anything need to manage on an infrastructure level, which is why we need to talk to Kubernetes cluster first. kubectl is a utility that we can use to manage Kubernetes cluster. If you want to play actually with big data clusters, we also have IZData utility. It also provides a wide ranges of commands so you can play with. We can also install Azure Data Studio, which can connect to TDS endpoint. So we can actually play with big data cluster through a graphic interface, which is very nice. Also, we have more capabilities. I'll show you in a bit later. From a monitoring point of view, you need to consider all the log metrics and logs collected from the agents. So for all the logs, it can be collected by free and bit. It can be stored in Elasticsearch and virtualized by Kibana dashboard. Also, we have Telegraph to collect all those Kubernetes live metrics and collect D to collect all those metrics related to SQL Server. And all those live metrics, they can be stored in InfluxDB and exposed by Grafana dashboard. For security reason, those two dashboards can be accessed from management proxy. We mentioned a couple of times all those proxies, all those public endpoints. So let's look at a security perspective for big data clusters. Then you understand why we do that. So firstly, from the user point of view, we talk to your API server of Kubernetes. So knowing that this is the infrastructure level, and from that point of view, so you're doing all the monitoring through the Kibana and Grafana dashboard. Actually, in that case, you communicate with the endpoint which is exposed by management proxy. Then you can see what's going on inside the big data clusters. If you're deploying big data clusters with Active Directory, knowing that you may create an admin group and user groups, and also you need to create OUs for Active Directory deployment with big data clusters. In the user group and admin group, basically is where you can define your existing Active Directory users and admins added to those groups so they can get some permissions to manage big data clusters, or just as a user, normal user, use big data clusters. And those parts which will give a very consistent experience when you're connecting to big data clusters using Azure Data Studio from your local laptop. Basically, it will connect to SQL master instances, and then when you play with Spark, play with HDFS, they also get a granular permission. When it comes to BDC cluster endpoint, we have 5 endpoints. So the controller is about a cluster management endpoint. The management proxy is open an endpoint to Grafana and Kibana dashboard. Also, we have endpoint open to SQL master instances. This endpoint is where you can use Azure Data Studio to connect to. Then comes to gateway endpoint. So this is the Knox gateway where you can write up data to HDFS. Finally, we also have app proxy. So app proxy is where we deploy applications, then it can expose to be consumed. To wrap up, you can use kubectl to manage Kubernetes clusters. If you want to interact with big data clusters, then AZ Data Utility and Azure Data Studio will be your great choice. The good news of these tools, because they are all cross-platform, so that means you can use them regardless your operating system. Of course, you can stick to Management Studio if you're a Windows person. It's still a great tool for configurations and management. To virtualize Kibana and Grafana dashboards, you can simply use your browser. Then how can we start work with big data clusters? So basically, your workstation, you need to set up all the utilities that we need to run Kubernetes, such as kubectl, and then we need to install AZ data commands so you can interact with big data clusters. We provide notebooks to automate those operations, such as install kubectl, install AZ data utility, regardless your operating system that you are using. And also, for set up your environment, we need to install certificates for Kibana and Grafana dashboard. We also have notebooks to do that. You'll get to that part in a minute. So if you notice, my background has been changed. That means we are getting to a demo. So in this demo, we're gonna start off by documentation articles. Then we're gonna deploy a real big data clusters on top of AKs. We also need to show off case some useful utilities also notebooks, and other tools that we provided to manage big data clusters. We're also gonna upgrade big data cluster from CU6 to CU8 in the demo. Finally, we're gonna show how to secure endpoint for Kibana or Grafana dashboard. So if you are ready, let's get started. Before starting our demo, as you may notice, my screen has been divided into 3 sections. So the first section is in a Linux VM. Linux VM is based on 1804. And then the second section is my laptop. For your information, I'm using Windows 10. Also, the third section is for Windows PowerShell terminal, and it's also on Windows, but just for additional checks. So to start a demo, I would suggest you to check out our documentation article. It's called Install Big Data Tools, where you'll find all the information you need to set up your workstation. To start off, let's do a few more checks here. Let's start on kubectl first. So the first check will start on if I have already kubectl available on my laptop, as well as the version, so which we can see here. Then comes to az data command. So all the az data command actually is a module that we can use to interact with BDC. So specifically, it's az data BDC plus what you are going to do. And then from that point of view, we can use az data to log into big data clusters. We can check out the cluster status, which we'll show a little bit later. I also installed Azure CLI for demonstration purpose because I'm using AKS in Azure. So here I just do a quick setup so I can have the access to my Azure Kubernetes cluster. Okay, as you may notice, I have access to my Azure Kubernetes cluster, and I can even see I have one node, it's ready. Also, I can check all the pods running in the namespaces. I can see I already have 4 namespaces available, which is by default in Kubernetes, which is the same in AKS as well. So now I think I'm ready for a new deployment for big data clusters. So now, in the first place, I think I need a deployment profile, which I use az data BDC config command to initialize. And I will choose a source from multiple options. Since we are in AKS environment, so I'm gonna choose one of the options in AKS environment. So I initialize my first deployment profile. If I go inside the folder, it's called demo BDC AKS, and we can see in this deployment profile, we actually have 2 files. So the controller.json and BDC.json. Let's have a look in controller.json. We can see in controller.json, it's nothing special than a JSON file. So inside this file, we can see some important information, such as we are deploying a CU8 as a version. One thing you'll notice is we are using load balancer as a service type. That is because I'm using AKS to deploy big data clusters. Also, for demonstration purpose, I'm gonna deploy in the first place a CU6, so we can use it to upgrade to CU8 afterwards. We just need to go back a little bit to see what are the settings can be modified in BDC.json. So as we can see here, we are using always the load balancer as a service type. So it's the same as we defined in control.json, since we are using AKS as a platform to deploy big data clusters. So this is a file that you can define some settings to match your requirements for the specific workload. So the settings related to Spark here mentioned, such as CPU usage, memory usage. Then as we said, we're gonna deploy CU6 in the first place, which is why here I'm also going to use az data command to replace the image version. Then we can check back. So in the control.json, we are having a CU6 has been configured. So basically now if I'm doing any deployment, it's going to be on our CU6 instead of CU8. So if you want to know more about customizable deployment with BDC, you can check out a documentation article, which I'll put a link here. It will give you some more information. Finally, if you are happy with all the settings we are getting here, we can kick off a deployment. The deployment process is quite straightforward. So I just need to give the username and password so I can use to log into big data clusters. Then I can use AZData BDC create command to create my big data cluster. So here, just for the purpose that you can see the whole process, which is why I opened a second section on my laptop, just to show you how it progresses in terms of deployment. So I can use a command kubectl get paths in a namespace that we defined, which is also the name of your big data cluster. Then we can see here that during the deployment, progressively we have different paths up and running. So after deployment has been finished, I can use AZData command to log into my big data cluster. We will also introduce an interactive login approach. Basically, it will require some parameters so you can log into big data cluster. Here, since I already saved those parameters as environment variables, which is why I can log directly. One thing to notice is this is not the only way to log into big data clusters. So after you log in, the first thing you want to check is to know our big data cluster, if it's healthy, if it's in a good state, which is why I'm introducing another command here just to help you to check all the components. So basically, you can show the different state of a different component, and all in all, it's in healthy state, which will kind of give you an impression to know if you have any problems. Then another command is very important is the BDC endpoint list command. This is the command will list all the endpoints available to you. That's exactly what we introduced in the presentation, all those proxy endpoints. Also, you can use the same command by specifying a flag. It will show, for example, the endpoint you want to display. Here we want to show for the cluster endpoint. And I want to know, for example, how to log into SQL master instances. This endpoint I'll copy, paste, because I use it to connect using my Azure Data Studio afterwards. Just to demonstrate my point here, we have a very consistent experience by using AZData utility to manage your big data clusters, which is why you can see on another window here, we use the same command, and the result we can expect is exactly the same, very similar behavior with what we did. Now I just go back a little bit to do a real quick check. What I explained here is we deployed the CU6 for big data clusters on top of AKs. So I just want to make sure it is the CU6 as a version. So I have two approaches to do this. Firstly, I can check for control part just to make sure it's using the image of CU6. So what I can do here is do a kubectl describe part command. As you can see from the screen, it just displays everything when I'm doing the deployment, and it shows very well I was doing the deployment with the image of CU6. And another approach I can show is using the kubectl get events command. So basically, this is a command to help you get all the events, what's going on your Kubernetes cluster. So here I just show what happened in a big data cluster's namespace. You just bring out all the what's going on, the events when working with AKS cluster. So we deploy the image, and you can see they're using a CU6 image. Then I can go ahead to do an upgrade. To do the upgrade, we do have a documentation article to show you end-to-end process how to perform an upgrade for big data cluster. What I really want to explain here is we can see through the whole process we perform upgrade. We start from the control plane, and then we perform, for example, the upgrade, which was driven by Watchdog, and then go down to different components and what we can see here. So after a few minutes, we can also check on the other side what's going on, how we perform that upgrade in Kubernetes cluster. So what is nice here is throughout the process, we see exactly what are components being upgraded here. And in the end, we also have a message to tell us the upgrade has been performed successfully. Of course, as it tells me, everything has been performed successfully. So just go back to do a real quick check. So I can see the cluster is healthy and we are already on the upgraded version, which is perfect. So now I'm taking the master instances endpoint with me. I'm going to Azure Data Studio. Here, I can use the endpoint and also username and password, which I can log into my big data clusters. So now I'm getting into big data clusters. With Azure Data Studio, it gives us a nice graphic view so I can see everything components that I can work with. Also, notice everything we've done with the AZData command here to show all the endpoints. We actually have a view in Azure Data Studio which shows you the same. And I have a nice button which you can copy the endpoint, then paste to the browser if you want to access to Grafana or Grafana dashboard, which is very nice. If we move the eyes a little bit, we'll see also we have a short link here. If you click on that link, basically it will take us to other notebooks we prepared for different operational tasks. So such as a demo I'm gonna show here to install a certificate for Grafana and Kibana dashboard. For anyone who has worked as a Kubernetes administrator, you may have a big pain on dealing with all those certificates. So basically, everything we've done is really in a hard way. Lots of commands, manually doing some stuff. Here, the good news is we have the notebooks to help you secure endpoint for the endpoint need to be secured in big data clusters. Like what I talked about for Grafana, a Kibana dashboard, and any other components, we do prepare all the notebooks for each of them. Here, we can have a look. For the whole section of set management, basically you can find all the notebooks to be used that will help you resolve some big challenges. Then the good news here also I want to show off here is we have one notebook, it's called 100. Basically, it will help you call out some other useful notebooks to secure all the endpoints. What you need to do is really to call out to execute this one notebook, then it will call out some other notebooks as well. Then it will go through each of them to secure endpoint. So now I just click on a button and let's see what happens. We'll go to do some demonstration here. So let me go to a Grafana endpoint here. Basically, I put my username and password. Then it takes me to the Grafana dashboard. So the first thing I'm gonna do is really to check about the information about my certificate. Good news is I already know connection is secure and my certificate is valid. Then I can check some more details by clicking on it. Then I can see all the information related to a certificate completed. So it's perfect. It also says my certificate is okay. So which means my endpoints are secured. So within 15 minutes, our demo covers everything around deployment, configurations, upgrade, the tools that we provided to manage big data clusters. So if you want to know more information about how to administer big data clusters, we do have documentation articles, because you can see here, and that takes you through the process and what are the tools we provided for some specific tasks. I hope it's useful. So if you are ready, let's go to the next section. Monitoring is one of the most popular questions from our customers. Of course, knowing what's going on inside your big data clusters is very essential to help you detect the problem as early as possible. So this section, we're going to talk about all the tools and measures that we provided to support your monitoring experience. So in this demo, we'll start off by documentation articles for all the references that we can give you to support your monitoring experience. Then we'll go to Azure Data Studio to see the management dashboard. So you can check out the first-hand information from the dashboard so you can see before diving into any other options what you can have already. Also, we're gonna also check out for Grafana, a Kibana dashboard to see what are the metrics and what are the experience that we provided for big data clusters. Finally, we're gonna get back to Azure Data Studio to check out all those notebooks that we provided. So real quick, let's get started on the documentations. Firstly, we have a few articles about how to get a basic information from the dashboard of the Azure Data Studio, which is very clear about the metrics that you can have. So basically, it's all the information that you can see through the dashboard with endpoints you can click through. We'll show this part a little bit later. Then we also have different commands that we introduced in a previous demo. One thing you need to notice here is about the view status. So this is a nice exercise because we used the view status command for big data clusters deployed in AKS. One thing I didn't mention, but I really want to show here is to help you monitor the different components here. Just take an example. If you want to know more about the healthy status or other information regarding the master or controller or any other components of big data clusters. So here is the command that you can use. Basically, it's the status show command. So here you just need to add a resource you want to check. It will give you a really nice output with the information as well as some URLs which can be displayed via the dashboards. Then it comes to all the dashboards, Kibana and Grafana. So you can see the articles about Kibana and Grafana. They're very detailed because if you can see, they really gives you where you can find those information. But of course, it's not about every single information, which is right here. We're gonna show also in the demo about some information you can get from the dashboard. If you have any questions for this part, we're also open for PRs. Welcome your contributions. Finally, one thing I need to highlight here, and I really want to do that, is about all the notebooks. So the notebooks regarding the monitoring and logging. The notebooks regarding the monitoring and logging, they are very useful because those are the efforts from the engineering team. And basically, all those notebooks, we have the descriptions. We'll give you the reference, which notebook you can use for a specific situation. Of course, you can always go to Data Studio to check out the details of each notebook. But I would recommend you start from the documentation articles because here is where you can get a reference which will help you when you really want to find something out. If you go back a little bit to Data Studio, the first page is really about an overview page which will give you some basic information. And if you go back a little bit, and we also have our information regarding our databases that you are working on. Are they healthy? Are they online? We also have a nice right-click menu here. We'll give you a quick access to the database that you want to work with. Then it comes to big data clusters. Here is where we can find SQL admin guides. So it's where we have all the notebooks. Then we also have all the endpoints displayed here, which we already showed earlier. Then it comes to Grafana dashboard. We have a lot to talk about for sure. Just for those who don't know about Grafana, Grafana is a multi-platform open source analytics and interactive visualization web application. Basically, it provides all the charts, graphs when you connect to your data sources. So here, we're going to talk about the metrics related to the Kubernetes level. So first, we'll start on the host node metrics. So it's about the worker nodes of Kubernetes, then down to the pods and container matrix. Then will be the components of big data clusters. So we'll talk about the SQL matrix and Spark matrix. Finally, we'll have a closer look about the app matrix. So let's go down the road. The first step gonna be the node matrix. Since I deployed big data clusters on Naked, so as you can see here, I have one node, which you can choose from the menu. So in case you deployed multiple node, you can choose also, then you can display all the metrics related to that node. Just for your information, I used a virtual machine as a node. They have 8 CPUs and a 64 GB memory. So which is why here in this page, you can find a lot of metrics related to the CPU and memory usages. Let's just have a look here. So in the first section, you can see some basic metrics, which gives you a general idea. And if you go down a little bit here, then it comes to the per CPU usage. As I mentioned, I have 8 CPUs. So here, they give you the matrix, each CPU, how much usages they're consuming at a specific point. You can see the memory usages down to the individual process. One thing I need to mention here is I have 64 GB memory here. In that case, each node will reserve amount of memory and CPU usages for the key Kubernetes components, which is why I don't have the full memory available. If you need more information about how to determine if you have enough compute resources, that's why we have to go down to the pod and container level. We can choose exactly what are the pods we're going to observe here. Also, it also comes down to the individual containers level. So for different pods, as we can see, they have all the pods we deployed for big data clusters, as well as in the container level, we have all the containers available in big data clusters. So here we just pick up SQL Server as an example. We can see all the CPU and memory usages. So it's very detailed as information. For some customers, if they deployed big data clusters on Naked or other cloud providers, they will find a network usage metric is very important because in a public cloud environment, they will be experiencing some throughput limits or latency issues. So the network usage here is very impactful when determining the performance of your workload running in a public cloud. For SQL Server metrics, it gives us more information related to the workloads. You can check out the transactions or other information for the last hours or last minutes, for example. And you're also free to choose, for example, which component you want to check out related to your SQL Server. Matrix that we're having here is more about a transaction. For example, you may notice many of my metrics here, I may have a peak time around 6 o'clock. That's because I did a restore database at 6 o'clock. Then you may notice around 9 o'clock, I also did some stuff. For example, I did a query. So I just checked out a query. So information value here is we have the information related to SQL Server as a whole. So the activity related to SQL Server for all the databases, and they give you a detailed view for the consumption versus all the activities happened on the database level. Then also comes to all the memory usages as well as the cache. For all the information that we are having here at the restore database, I also did a query just to check out the top 1,000 records here. As you may notice, all the packs here are related to what I was doing at that point. Then it comes to Spark metrics. Very similarly, I deployed a few Spark apps there. If you notice, all the data points here related to what I was doing. As you may notice, the JVM heap usage consumed by my Spark applications here, so I have a detailed view about all of them. For most data scientists and data engineers, they may turn to use more often the Spark history server. Here is just a reference view to give you more insights. Finally, we also have our metrics ready to the apps deployed on top of big data clusters. So you can choose applications of your choice as well as the version. The basic information we've provided here is about our CPU and memory usages. For developers, I also have some reference metrics as you can see on the same page. When you're having applications on BDC, the applications on big data clusters consume the big data, which resides on the same cluster with them. So it's a great benefit in terms of a lower latency as well as a better performance. If you want to know more about app deploy, I have a short link here. You can have a look, which will give you more information. Then it comes to our notebooks to support your monitoring experience. We can always say, for example, if you start to monitor from a Kubernetes level, we also have a first page to have our reference to different notebooks here. Then it comes down to big data clusters. You can also check the first page. You have all the notebooks as an index that you can choose then to help you monitor some specific components. I just want to give you an example here. So if I go back to the monitor Kubernetes notebook here, so in the first page, I can see I have some notebooks related to the storage. I just want to know, for example, in my case, since I deploy big data clusters on AKs, so I just want to know what are the storage class available to me. Then I find out the notebook can help me to get all the storage class. As you can see, the output of the command gives me all the storage class available for me to choose. But to me, it's not very clear because I want to know, I deploy big data clusters, what is the storage I'm using for different parts, and also how much storage I used, which is why I'm going to check out another notebook. It's called How to Get the Persistent Volume here. So if I check out that notebook and just to try to run a notebook, and I get a result here. So actually I have a list of all the different persistent volumes, all the PVs for a different part here. I can also see how much storage I'm using for each part. But for me, it's not very clear because I know for the persistent volume, I need to know the PVC to know exactly how much storage and what is the type of storage I'm using, which is why I come to the third notebook here to get all the PVC available. So with the output of this notebook, this is where I can see all different parts running on my big data clusters. What is the storage they are using? I can find the type and as well as how much storage I'm using for this part. So different notebook will give you insight about how to check a specific component, but in some cases, just like I did, to know more information about the storage, so I checked the 3 different notebooks in combination. That gives me an insight about what I'm looking for. So for diagnosis, this is a very useful section with other notebooks. Will give you some information about the current state of big data clusters, such as the CPU and memory usages, or if you want to know, for example, the global state of big data clusters, especially when it comes to you want to check some specific usages for a disk or for a component. We have tons of notebooks here will help us to diagnose the problems. So, for example, if you want to check out the CPU and memory usages for all the containers, we have a notebook for that. If I just do a real quick test here, as you can see, as it goes through each step, I can see exactly what are the containers, and then checking. Also, for each container, I can see exactly the CPU and memory usages, which detailed even down to the individual process. So it's very clear, helpful to give you a little bit of guidance to have that view. So all those information is in the table view. So basically it gives you the, for example, what is the process user must understanding CPU and memory usages. Then it does to name other containers we consume the computer resources. Then it comes to log analyzers. Here is a set of notebooks will give you all the automation scripts to analyze the logs of each component of big data clusters. So the first page, as you can see, they have a nice index which you can check out. Now I'm just taking an example. I want to have a closer look for the controller logs. So here I just find out a notebook and then click. Then I can see actually all the authentication go through the controller. Basically is when I was connecting to controller endpoint. Yeah, so I didn't find any exceptions here, but if I did have some problems, they will display here as well. Then for most DBAs, you're mostly interested in all the SQL Server error logs. Here we also have a notebook which will help you to identify some risks, especially when you're having some exceptions, which are mostly more general ones. As you can see here, it's kind of give you a look about our tail of the logs. So basically, it also displayed as a table view. You can see what's going on. All the information displayed in a section, so you can check back as well. To check out those logs, even though you are DBAs, maybe in some cases you're not familiar with other commands and scripts you can work with Spark, we do have notebooks here to help you out. Similarly to data scientists and data engineers, if you want to know more about for SQL, we also have logs here. Because big data clusters, we have so many different OSS components, so maybe you're more familiar with one another than other. So here is a good chance to help you out. We are continuously working on these notebooks, so our goal is really to be covering all the essential critical aspects of management, administration of big data clusters. So if you have any suggestion, also please feel free to share your feedback. Then it comes to Kibana dashboard. We also have lots to talk about. Just for anyone who doesn't know about Kibana, so Kibana is part of the Elasticsearch. So basically, it's an Elasticsearch stack. They have a couple of software in the pack. Basically, Kibana is a part which is an open source data virtualization dashboard for Elasticsearch. In the context of BDC, basically we have all the logs collected by FluentBit, and they can be stored in Elasticsearch. Also, to take advantage of the Elasticsearch, we have incredible capability to search all the logs. So here, if you have a detailed look for the Kibana dashboard, here is where we can find the logs related to the containers. If you can see the main dashboard, we already have all the logs. Also, we can check, for example, if I were to go back to check on my log for yesterday or the day before, it's very easy. And I can click detailed. It will give me a table view, or I can also choose a JSON view as well. Then come to my left side. Here is where we can filter by container type, such as I just want to know about everything related to security support. So then the security support will be highlighted against the other logs here. Also, if I want to go back, for example, to say I want to check the logs for last month, it's a very flexible menu here. The diagram on the top also gives us a very clear view about the general impression count about the logs. It can be also filtered by time. Troubleshooting is another myth when working with big data clusters. But I believe from what you learn from the monitoring section, basically you'll get the idea of what are the problems or roughly what is your problem. So this section we're going to talk about what are the measures and tools that we provided to help you out. You can dive into each component and to troubleshoot what are the real problems and how to resolve them. Before we get into a demo, I just want to do a quick recall about architecture of big data clusters. By far, we saw about big data clusters, so from a product perspective, we know we have master instances, we have compute pool, we have data pool, storage pool. Of course, it is important to know about big data clusters had those components. But behind the scenes, to also recall another view is it works with Spark. It also has SQL Server, we have HDFS. When it comes to troubleshooting, we do need to consider we have that additional view here. Everything we saw from the monitoring capabilities, basically we know about how to monitor the different components of big data clusters. We collect logs, we have those information. All those information could be very useful to help you where is a problem, which is why we always start on the documentation articles. The whole section which you can find from SQL documentation about big data clusters. We have a section for troubleshooting. So the troubleshooting, we introduce start from Kubernetes level, check out if you have any problems on your infrastructure. Basically, the command use kubectl, for example. You have the whole guidance in that article. All the commands are available to use to help you find the details from the logs, as well as to understand the problem on the infrastructure level. We also have notebooks for each individual BDC components. So here is ready to help you find that entry point and use a command, check out the problem. You can also copy some logs, for example, which will get you to understand more details. Then the notebooks are there to help related to some specific problem. You can pretty much find all the standard use cases in this section. So those information articles are based on the real-life feedback from our customers. Those articles are the best place to go if you have any questions. Then it comes to all the problem related to Active Directory. We have the guidance here. If they are the actual problem you are having, basically you can follow the steps to help you resolve the problem. Otherwise, we also have the whole set of cluster troubleshooting notebooks will help you out. So it's really about from the different levels will help you detect the issue, analyze the issue, as well as repair some potential issues. I keep talking our notebooks. We also use some notebooks to do monitor the Kubernetes clusters, monitor BDC, also some components of which we are using for BDC, just to collect those information to gain more insights. Yeah, so here we are going to talk more about the troubleshooting using the notebooks. As I explained, basically we collect all the scenarios when we are customers or users having the problems, or ourselves when we are having problem, how we resolve the problem. Those notebooks, including all the automation scripts inside, all the documentation articles. As you can see, If you go inside to Azure Data Studio, we need an additional view because we know about the components of big data clusters. We have SQL Server, we have HDFS, we have Spark. We continuously working on that. But you can see from the troubleshooter page that it gives you a really nice index which will link you up to other useful notebooks in other sections. Another thing I need to mention is really useful is we have a section for repair. So those are the scenarios we collected from ourselves or from some customers. If you check out inside, we have a description for each notebook. Basically, in the will you can find what are the scenarios and under what condition you can use them. If you want to know more about big data clusters, please feel free to check out our documentation articles, which we put a short link here. And if you want to do some hands-on stuff, we also have SQL workshops specifically for big data clusters. Also, check out the SQL samples here. So hopefully those examples will be helpful when you're working with big data clusters. Specifically, I would encourage you to join a session of my colleague Daniel and Rahul. They're going to talk about everything you need to know as data scientists and data engineers. Also, if you are interested in OpenShift platform, I would encourage you to join the session of Mihaela. She's going to talk about everything around architecture and anything else you need to know when working with OpenShift and big data clusters. Thanks a lot for joining. There's a lot of information, but it's all about learning and growing. Please feel free to share your questions here. We are happy to take any questions you may have. Enjoy the rest of your conference. Hope you have a lovely day.